Biologists are studying a new bacterium. They create a culture with 100 of the bacteria and anticipate that the number of bacteria will double every 38 hours. Write an equation for the number of bacteria B in terms of the number of hours T since the experiment began. So what's important is that we understand what's the given information here, that we start off with 100, and that this is going to be an exponential growth. Because, how do I know that? Because this is saying that there's going to be a ratio, and the ratio is going to be doubling every 30 hours. This is key, that this is going to be a geometric growth, or an exponential growth. So, and they want us to use a letter B here, so I have B is equal to some starting value, which I'm going to call A, and this is going to definitely be geometric or exponential, so I'm going to use the base here. I'm going to call that R raised to the T. And I know that the starting is 100, so that's the leading coefficient. I don't know what R is, I'm just going to call it R, but I do know that in 30 hours, that I'm going to have doubling of what we started with, so that's B has to be 200. Let's divide both sides by 100. I end up with 2 is equal to R to the 30th. Let's solve for R. So to do that, I'm going to raise both sides by the reciprocal of the power of 30, right? So I'm going to raise both sides by 1/30. So R will equal to 2 to the 1/30. So now that I know what R is equal to 2 to the 1/30. And again, if I did that a little quickly, my apologies. Let me just do that really quickly again. So again, both sides to the 1/30, right? So the exponents will cancel. I'm left with R is equal to 2 to the 1/30. So now that I know that B is therefore equal to 100 times 2 to the 1/30 to the T power. And this is the equation that they are looking for.